Hi everyone, this is Ruby, and today I'm going to talk to you about conceptual exercise 16.3 from the PTPA textbook, because this is a good way not only to rank the brightness of bulbs relatively to each other, but also a good way to understand how currents work, even in more complicated circuits like the one shown in this diagram. So the problem says, 4 identical bulbs are connected to a battery as shown in figure 16.14. Rank the bulbs according to their brightness in decreasing order. If 2 or more bulbs are equally bright, indicate that in the ranking. So first, let's look at our schematic diagram. We have our battery, and then we have all of these light bulbs, 4 light bulbs. So here we have number 1, which is on a parallel branch, numbers 2 and 3, which are in series with each other. And then out here is bulb 4, which is, if you think about it, in series with this whole parallel circuit. So from the textbook, we know that the answer is going to be 4 has the highest brightness, then next comes number 1, and then next comes number 2, which is equal to number 3 in terms of just how bright they are. And the textbook does a good job of explaining why this is, but I want to go through it just so we cover all the cracks, because I was wondering myself about the current and exactly how brightness works when I was going through this, so I'll just save you the time. So let's say a standard circuit is just a single light bulb connected to a battery with wires in a complete circuit. So no parallels, no series, just a simple light bulb in that circuit. And just like that, we can compare the current of a standard circuit to other combinations. We know that when 2 light bulbs are in series, the current running through each of them is half of the standard current, because each light bulb provides more resistance, so the total current running through that section, the section that's in series, drops. And then when 2 light bulbs are in parallel, the current running through each of them is equal to the standard current. So if you put 2 light bulbs in parallel, then they should be the same brightness, and then the total current of the whole circuit is going to be twice the standard current. And using this, we can look at the original problem using the circuit construction kit. And I've already set up this whole contraption here. So here's the battery, then we go to, this is bulb 4, and then on the parallel branches are bulb 1 and bulbs 2 and 3 in series with each other. And as you can see, just from the picture, we have bulb 4 as the brightest, bulb 1 as the next, and bulbs 2 and 3 as the least bright, both equal to each other in terms of brightness. So in that sense, we have confirmed what the PTPA textbook says is the answer, but let's look at how you do that. So I was wondering, and this is probably going to be a popular misconception, which is why I made this video, I was wondering if the current of one branch of a parallel circuit had to be equal to the current of the other branch, because in our examples from the textbook we had one light bulb parallel to another light bulb, and they had the same exact current running through each of them. But in this case we have 2 light bulbs versus 1 light bulb, so then I wondered if the total current over here would still match up. And it turns out that it doesn't, and I'll show you why. So you take your non-contact ammeter and you can measure the actual numbers. So here we have 0.18 amperes going through the branch of bulbs 2 and 3. And then if you go over here, we have 0.36 amperes going through the branch that just has bulb 1. Then when I saw this, I started to think, well, why would that be? And the reason is that here we have the 2 bulbs in series. So when you have the 2 bulbs in series, they lower the current of the branch that they're sitting on. So in this case, since there's 2, we just divide what the current would have been, which is 0.36 as shown on this branch. We just divide that by 2. So that's why we get 0.18 amps. And in this sense, we can see that the total current running through this section is actually not equal to the current running through this branch, because it's half of it. And this shows you that the branches in a parallel circuit do not necessarily need to have the same current. What really matters is how the setup goes as far as series and parallels within that parallel circuit, and also the number of light bulbs or resistors that are involved. Now the next thing I thought was that the current running through this light bulb 4 in the original diagram, should equal the total current of this section because, as I said earlier, light bulb 4 is essentially in series with this parallel circuit. And as we know, when two light bulbs, or two units, I'll say in this case, are in series, they should have the same current running through them. So I decided to test it by looking over here, and indeed this is 0.54 amps. And 0.54 amperes is equal to 0.36 amperes plus 0.18 amperes. So this whole sum over here, the current of the parallel circuit, is equal to the current that's running through just bulb 4. And so the total current of the whole circuit is equal to 0.54 because if you think of the series again, then when two things are in series, the total current is the same as the current that runs through each bulb in that series. So we have 0.54 for the whole circuit. And this brings us all the way back to our original answer of 4, which is greater than 1, which is greater than 2, which is equal to 3.